Okay, what about a problem with right triangles that involves sine, cosine, and tangent? Do you have something like that? I'm glad you asked. It's your girl Tiffany from Tiffany's Tutoring and Consulting LLC, and I'm guiding you through these education streets. SAT edition. We're still in practice test number 4. So let's get into this. So now we have a problem where we have right angles, but we also have cosine, tangent, and we don't have sine, but you get the idea. We're into trig. In triangle JKL, cosine of k equals 24 over 51, and angle J is a right angle. What is the value of cosine of L? So the first thing we're going to do is draw our picture, right? So we want to make sure we have our picture here. And we have our angle here. Let me clean this up a little bit. We want our right angle to look a little straighter. Again, it doesn't matter exactly. Not looking for perfection, but redraw it a little bit. All right, it says J is our right angle. So we're going to label J. K and L don't matter because the main thing is that J is correct as the right angle. All right, so let's talk about cosine, sine, and tangent. So cosine of an angle is equal to the adjacent side divided by the hypotenuse, HYP. The sine of an angle is equal to the opposite side divided by the hypotenuse. And the tangent of an angle is equal to the opposite side over the adjacent side. So let's talk about these sides, right? Opposite means across from, okay? The hypotenuse is the largest side or the side that is across from the right angle. So we know that in this case, it says cosine of K is equal to 24 over 51. We know that 51 has to be a hypotenuse and 24 has to be adjacent to K. Now it's adjacent to the relative to the angle that they're talking about. So the hypotenuse is 51. That's just going to be 51. So I want to actually look at K, right? K is here. I want to find the side that's adjacent or next to. If I look at JL, that's across from, it's not touching K. JK is touching K. So 24 is here. Now you might be like, okay, this is great, but I need the cosine of L. And to get the cosine of L, that means that I need the adjacent side, which I don't have. But we can find that. I'm glad you asked about that. Let's go ahead and find that x, okay? So what I'm going to do is I'm going to take that and I'm going to use the Pythagorean theorem, which is what I had from a previous formula to solve for x, okay? So it's a squared. It doesn't matter which one is a or b. A or B doesn't matter. What matters is C matters, okay? And then what I'm going to do is I'm just going to algebraically solve for A. So I'm going to subtract 24 squared from both sides. You could write it out. You could leave it like this. It's really your business. But make sure you're doing inverse operations. The inverse of squaring is to take the square root. Okay. So I'm going to take the square root of 51 squared minus 24 squared. And that's going to get me right on down to 45. Okay. So I have 45. Now with this problem, I'm going to go ahead and finish it out. And then I'll tell you what the answer key was a little interesting. Cosine of L is going to be adjacent to L. So that's X is 45 over 51. In the answer key, they had it simplified, which I can simplify that down in lowest terms and get 15 over 17. It also had the decimal equivalents, 0.8824, and it also has 0.8823 as a potential answer. I personally like leaving it in just lowest forms as a fraction. That way, you don't have to get into how many decimals you need to round to. It didn't say it, and it may accept the equivalent. Just to be safe, I would say the simplified fraction will give you the exact answer. I hope this helps. I'll talk to you guys later. Peace.